Hello everyone, myself Nandan, AML department, 5th semester. Here, these are my friends Nikhil, Chinmay, and Kushal. We are going with our assignment one of course name Advanced Machine Learning, and the course code is UE23AI3501. This is our assignment one problem statement comparing ensemble versus single models, and this is guided by Ma'am Akshata, AMS, Assistant Professor, AIML Department, GM University, Davangere. And these are my team members, Kushal, Chinmay, and Nikhil. And coming to the next, we have the introduction here. This is in for our problem statement. In machine learning, predictive models can be broadly categorized into single learners and ensemble methods. A single learner such as decision tree makes prediction based on the model trained on the dataset, where the decision tree used to predict the model trained on the dataset. And while it is a simple and interpretable, it often suffers from overfitting and high variance. There is a high variance due which falls to overfitting. This is the main problem in our algorithms. In the next slide, we have objectives. What are the objectives we have? We are comparing a single learner decision tree like and with an ensemble method like the random forest. We use here the decision tree and the random forest as ensemble methods, evaluating both models using key classification metrics and analyzing how ensemble learning reduces overfitting and improves generalization. To improve the generalization, we used here an ensemble method and to reduce the overfitting. In the next slide, we have data set selection and preparation. What are the data set we used here? For example, we used the breast cancer dataset from skeletal binary classification. We used here features 30 attributes describing cell nuclei and target, 0 malignant and 1 benign. Pre-processing like split data into training. When we select in any algorithm, they split the data into training and the testing of 70 and 30%. Feature scaling not mandatory. Tree-based models are scalable invariant. In the next slide, we have a model training. We used here decision tree classifier and the random forest classifier. In decision tree classifier, algorithm are cart, classification and regression trees. Key parameter, random state 42, simple interpreted but prone to overfitting. Ensemble of multiple decision trees. Key parameters and estimate 100 number of trees and use bagging to reduce the variance. We use here bagging. In the next slide, we have model evaluation matrix. This will be continued by my friend Nikhil.
Coming to model evaluation matrix, in that precision, recall, FN score, ROC and AUC. In precision, correct positive predictions and total positive predictions. In recall, correct positive prediction divided by actual positives. In FN scores, harmonic means of precision and recalls. ROC and AUC, ability of the model to distinguish between classes. These are the model evaluation. And next slide. These are the evaluation result. Matrix, decision tree, random forest. In matrix, precision coming to decision tree 0.92. In random forest 0.9. In matrix recall, decision tree 0.94. In that random forest 0.96. In FN score, decision tree 0.91 and random forest 0.96. In matrix ROC and AUC, in decision tree 0.93 and random forest 0.99. And next is continue by Chinmay.
Hello everyone, here is a ROC curve. ROC stands for receiver operating characteristics. It is the result of our code and output of our code. And for comparison and analysis, it trains on multiple random subsets and it reduces dependency on any one sample. And in next, it combines multiple trace smooth decision boundary, and it lastly decreases overfitting and improves robustness. Random forest performs better on all metrics due to averaging effect and re- re- reduced variance. In next slide, how ensemble methods control overfitting. First, it bagging each tree trained on random samples lowers variance, and next averaging. It combines predictions, reduces noise, and next diversity. It trace see different data futures, decorrelated errors. In last ensemble, it many weak learners or one strong stable model. And lastly, conclusion, decision tree, it is a simple interpretable but high variance. And next, random forest, it is more accurate, stable, and generalizable. And next, assemble methods effectively control overfitting and improve real world performance. And next, the code will be explained by my friend Kushal.
Thank you, Chinmay. Now I am going to explain the code part. Here we are importing some libraries, Python libraries like pandas and scikit-learns, and we are importing the breast cancer datasets from sklearn. Here we have to train the model in two types. First one is test and split. Train the data and test and split the data. And we are doing a pre-processing steps of the data. We are importing a decision tree and random forest for ens- we are classifying for ensemble versus single mode. So we used decision tree and random forest. Here we used four matrices like precision, recall, F1 score, and ROCAUC curve. Here we use matplotlib as a library. Here to load the data sets. Here we declare as the x and y variables in step 2. Split the data into train and test set. Here we training a data and test and split. And the future scaling is scalar is equal to standard. Next, and the fourth step is train a single mode. Here we use single mode, we use as a decision tree. Decision tree classification. Here the random state is 42 we are taken, and the prediction. And the sixth step is evaluation matrices. We are making four evaluation matrices like accuracy, precision, S1 score, and ROC curve. And it prints the model accuracy and the performance. Model name and performance. Model name is print accuracy, precision, recall, F1 score. And step 7 is ROC curve comparison. Comparison of the ROC curve from decision tree and the random forest. And it shows the graph of the decision tree and random forest. And print the ROC curve comparison. Here we use the false false positive rate and the true positive rate. And eighth step is comparison table. And comparison table means result on the data frame. Here comparison is model means we are taking decision tree and random forest and comparing those matrices like accuracy, precision, recall, F1 score, and the ROC AUC curve, and print the model comparison results. And it prints the results. Here the output of the is the data set is loaded successfully, and the shape of the data is 569, 30. And target class is malignant and tumor. As we know about the from past, malignant means we are taking binary classification. Malignant means 0 and benign means 1. Malignant means it is a cancerous cell, and benign means it's a non-cancerous cell. Here the performance of the decision tree is accuracy is 0.947, and the precision is 0.977, recall is 0.9, and ROC is, these are the random decision tree. And the random forest performance is accuracy of 0.96 and precision 0.95, recall 0.98, F1 score 0.98. And this is the curve of the ROC curve comparison. Here we are taking y-axis true positive rates and x-axis as false positive rate. This is the here the dotted line represents the decision tree comparison, and the thick line, a single line, it shows the random forest. These are the code, and this is the output of the result. Thank you.
Thank you, everyone.
Thank you.